In this lecture, I'm going to show you some basics of LaTeX. LaTeX is a typesetting language that is used very frequently in scientific publishing, and we're going to ask you to submit papers using LaTeX. We've given you some details about the website Overleaf. So Overleaf is a service where you can write papers in LaTeX or write text in LaTeX, and it automatically then renders the code that you've written into a PDF file that you can download. And Overleaf is free to use to you, so if you use your UCI email address to log into it, it should give you access to all of the features. And when you start, the first time you log in, it will look Overleaf will look empty like this. But and you can start creating projects if you like. But we have created for you a template that you can use that sits under this link here. And if you go to that link, which we will share with you, then you'll immediately see a draft paper render here on the in the right panel, and in the middle panel you see a bunch of code that I'll talk a little bit about in a moment, and in the left panel here you see a list of files that exist. Now you will immediately notice if you start playing around here that you can't edit anything. So I'm pressing buttons now. You can't edit anything in here. That's on purpose. What you're supposed to do instead is hit this little up arrow at the top left, which will bring you, if you go to all projects where you should be, which will bring you to a list of files or a list of projects that you're associated with. And what you need to do here is click the first of these icons, copy, to make your own personal copy of the project. And then you will be able to edit it. So I'm just going to name mine JV, make a copy, and then you'll see there's a new project that's popped up here, owner you, and modified just a few seconds ago. And if you edit that, if you go in there, you'll see that you'll see the same view here with the same paper, but now you are able to edit the file. So first of all, LaTeX is a programming language of sorts. So it has all these commands up here that are mostly packages, so other bits of code that are being loaded in. But the main thing that it's supposed to do is dissociate the content from the form of a paper. So the idea is that you tell LaTeX what your title is. So for example, you have this backslash title, and then in curly braces you can write the title, and then LaTeX will figure out where titles go on pages, right? So you don't have to do the typesetting, it does it for you. Similarly, there's an author function here, so in the author function between the curly braces you can put your own name and your student number. So I'm just going to put my name here, and you can write, there's a date function where you can write anything. Just because it's called date doesn't mean you have to write the date there, but we'll ask you to write COGS 110 midterm paper slash comma slash backslash today, and today will render today's date on the paper. Now you'll notice that I wrote my name here, but this the right panel hasn't synchronized. That's because I haven't pressed the recompile button yet. But as soon as I do that, it takes a second, and then LaTeX will figure out that my name goes here. Now I really like, not everyone likes this, but I like this compilation to be automatic. So I always set this to on, and now if I make a further change, like so, and I leave it a second, then it'll automatically compile and put my name there correctly. So now you have your paper here that you can where you can start editing. A few things you need to know just so you don't break LaTeX, so making sure that everything will keep working. The first thing you need to see is this little number 1 here. So this little orange label means LaTeX has some issue with something, but it's not serious. If this becomes red, then you've broken something. And most commonly the things that you'll have broken are either you have opened a curly brace somewhere that doesn't have a closing mate, or you've used a special character somewhere and LaTeX doesn't know what to do with that. So the main special characters that you want to avoid are the $sign, which you only want to use if you're writing math, the percentage sign, which you'll want to use a lot, but it lets you comment things that write comments that are not generated into the LaTeX, into the PDF file. You'll absolutely want to avoid the ampersand unless you are making tables, because that's what the ampersand is for. And then there are a few others. For example, the underscore is something that LaTeX doesn't like. So if you use any special characters at all and you notice that your LaTeX file isn't compiling, see if you can remove some of the special characters and see if the little red label goes away. Now, the main things that you'll need to do to write a paper are obviously write text. So you can write text pretty much as you otherwise would. In order to tell LaTeX to make a line break, so a carriage return, start on a new line, you just have to have an empty line here so that it knows how to do that. And if you want to insert sections, there's a section command here that says /section and then the title of the section, and then LaTeX will figure out this is its own text section of text, and I'm going to typeset that the way that I want. Note that there's a little star here. What that usually does is it changes the section formatting from having a number to not having a number. So we don't want numbered sections, so we put that star there. Now, when you're writing a paper, especially if you're writing an empirical paper, you will want to be able to enter tables and figures. And if I scroll down, you'll see a whole bunch of code here that has lots of functions in it. It starts with begin table, so that should give you a hint that that a table is about to happen, and it ends with end table. Now you will never have to actually type this in. That is generally bad practice. If you find yourself typing in numbers into or typing in values into a table in a scientific paper, you're doing something wrong, because that's just inviting errors. What you should instead do is copy paste from wherever you're generating the numbers, or of course you should have whatever is generating the numbers spit out the tables that you can paste in. So for example, if you're using JAGs, as I am, so I have my analysis here of the shape perception data. I haven't changed anything to it, and I've got this output window here. Now JASP very cleverly, it lets you copy tables immediately in LaTeX codes. If you click the little downward arrow here, you can copy the table to paste it into Word, but you can also copy it to paste it into LaTeX. And when I do that, I'm going to make some white lines. LaTeX doesn't care about extra white lines, and I do Control V to paste. A whole table is generated, so I just pasted this entire bit of code. You can see my my table starts to show up here, especially if I had recompile. Alright, so here's a second table in addition to the one that was already there. Now you'll also see LaTeX has something to complain about. There's a little red flag. You can click on here and sometimes it tells you something informative, but most of the time it doesn't. But in this case, what's wrong is that when I copied the table from JASP, JASP also tells you that you need to load this package book tabs, but you only need to do that once. So you can delete this line, because you see if I go all the way up, book tabs is already loaded here. Right. So you can just delete that line, and then the complaint goes away. So that's how you paste a table. You can copy a table from JAGs into LaTeX very easily. If you want, you can start editing these tables, but that is an error-prone process. So the things you need to know about that are, the numbers of the values in the table are here, and these ampersands are column markers. So these separate the last column from the second last column, and so on. So if you want to remove columns, for example, you can just remove values like that. You can delete values. And I already made a mistake. So you can delete values like this. Should you want that, but in general, I recommend you just leave everything where it is, because if you start changing tables, you're inviting error. So that's how you add a table. Again, you can all of these little LaTeX codes. They're functions, and there are things you can change. So, for example, there's a function here, caption, that tells you what the caption of the paper is going to be. And of course, I can change this to a different caption if I should so desire. And then you'll see if you let LaTeX compile that the caption has changed. Now, the second bit that you really need to know is how to insert figures, because again, your analysis will sometimes generate figures. Now, JASP lets you save figures. If you hover over any panel and you see this little downward arrow, you can copy your figure. Sometimes you can copy citations, but that's usually not very relevant. Or you can save the figure to your computer. So you should just do that. Save, give it a name. My figure, like so. Right, and if I now open my file browser, I can see my figure there. So this is locally on my computer, but now in Overleaf, in this left menu here where the files are being managed, you can make a new file, you can make a new folder to organize your files if you have many, or you can upload. And if you upload, this clever little window pops up where you can just drag figures into or drag other files into. And once I do that, you see that the PNG file, so the figure file, is now available here. And if you scroll down in the LaTeX code, you see that there's this chunk of code here that starts with begin figure and end figure, and right in the middle of it is the name of a file, which you can change. So I'm going to change this to my figure.png, and LaTeX will update, and now that figure appears there. You can do a lot more here. You can, for example, change the size of a figure. So currently it's set to span about half of the text width. But if you want to make it bigger, you can do it. You can do that by increasing the fraction of text width. But this is, of course, quite big. You can change the caption, which of course you should. And there are lots of other things here that you could, in principle, change. But most of it, again, you should probably just leave alone. A third thing you need to do, or need to know how to do, is how to add references to your paper. LaTeX comes with an automatic reference manager, which is extremely convenient. So you can see here in the example, there is a sentence. You can cite references like this, and then it shows two functions that look very similar. There's \cite capital A. Note that LaTeX is case sensitive, so capital A is not the same as lowercase a. And then a code. So this code is also known as a tag. So this is a reference to a particular paper, or in this case to a book, to the Hitchhiker's Guide to the Galaxy. And there are two ways where two functions that are compared here. So there's cite A and cite. And if you look at the text, you can see that they do look slightly different. So cite A, the A is for author, emphasizes the author, and then gives the year, whereas regular cite puts everything in parentheses. So these are two ways you can cite references. Now, LaTeX doesn't innately know that this tag is related to a particular book. You have to tell it that. And the way you do that is among these files here, you'll see references.bib. If you click that, this is a text file that is another code file that says there is some book. I'm going to give it this tag, and here's the information about that book. And LaTeX can read, so Overleaf can read this, and it's going to interpret that, and it's going to see, well, if you're talking about this tag here, then I'm going to refer to that as Adams 1995. And furthermore, at the bottom of your paper, I'm going to add to the reference list the correct reference to Douglas Adams. So this is very convenient. You never really have to worry about your reference section if you're dealing with LaTeX. Now, you don't have to write these blocks of code. You have to go find them instead, and you can usually find blocks, these BibTeX entries as they're called. You can find these BibTeX entries on Google Scholar quite conveniently. So if you have a paper you want to cite, you can go to Google Scholar, and for example, I want to cite Scamander 2001. Scroll down a little to find it. This here is Scamander 2001, and Scholar has this little citation, this little double quotes that you can click, and it'll show you different ways of citing this book. But the way we want is the BibTeX here, and that provides the BibTeX code for you, which you can just copy. That's not the right window. Copy and paste into your references.bib file. And then if you go back to main tech and you replace this reference to Adams by reference to Scamander and let it compile, you'll see that the name changes here, and the reference changes, and also in the reference list the correct reference is added. So that's how you add citations. There are many other ways of citing, but these are the two that are going to be the most convenient. Finally, two more things that you need to know about using LaTeX and Overleaf. One is you can count words of your paper, because we don't want you to have to manually count these words. So in order to do a word count, you can click on Menu here, and it just has a function word count. It takes a second, and it'll tell you currently your paper has 323 words, and we're aiming for 2,000 to 2,500 words per paper, certainly not more. And then very finally, once you're done and once your paper looks nice, there's this download button here, and bam, this downloads your paper into a nice beautiful PDF file. So that's how you use LaTeX on Overleaf. This is not LaTeX has a bit of a learning curve, so we know that. So you're not going to be an expert of this immediately, but the both of us are somewhat experts at using LaTeX. So if you run into trouble or if you have questions about it, you should feel free to ask those on the discussion forum.